Since there are many ways of representing a given rational number as a fraction, we want to have a standard way of representing a given rational number so that we can easily tell at a glance whether or not two rational numbers are equal. Now, if our rational number happens to be an integer, the integer representation is the standard representation. So, for example, we would write the number 3 instead of the fractions 3 over 1, 6 over 2, 90 over 30, and so on. Okay, what if our rational number is not an integer? If a rational number is not an integer, the standard way to represent it is as a fraction in what's called lowest terms. What does this lowest terms mean? A fraction is in lowest terms if its numerator and denominator have no common factor. That is, if we can't come up with another integer that we can divide both of them by and get integer results. So, for example, the fraction 6 over 8 is not in lowest terms, since 6 divided by 2 is 3, and 8 divided by 2 is 4. Those are both integers. In fact, if we take 6 divided by 8, that's equivalent to 6 divided by 2 over 8 divided by 2, 3/4. The reason for that name, lowest terms, refers to the fact that this is the representation with the smallest possible numerator and denominator. The process of writing a fraction in lowest terms is called simplifying the fraction. You'll sometimes hear this referred to as reducing the fraction, but I don't like that term for it, because reduce seems to suggest you're making something smaller, and in fact the fraction continues to represent the same number. So how do we go about simplifying a fraction? One method works especially well if the numbers are small and we can easily see what their factors are. In this method, we will pick a common factor of our numerator and denominator, divide by it, and then keep going until we're out of common factors. So, for example, suppose we have the fraction 12/18, and we immediately spot that 2 is a common factor of those two numbers. They're both even numbers. Oh, but now we spot that 6 and 9 are both multiples of 3. And now we notice that, okay, 2 and 3 are both prime, no common factors left, we're done. Or maybe we could have done that by immediately spotting that 6 is a common factor of 12 and 18. And then we would immediately get 2/3. This method works well if the numbers involved are relatively small or have easy to find factors. If we have larger numbers or numbers with hard to find factors, we may need a second method. In the second method, we factor the numerator and denominator into what are called prime numbers, numbers with no factors other than themselves and 1. And then we cancel or cross off any factors that appear in both the numerator and the denominator. To factor into primes, we typically use a factor tree. So, to factor 12 into primes, we might say, well, 12 is 3 times 4. 3 is prime, but 4 is 2 times 2. 2 is also prime. To factor 18 into primes, we might say, well, 18 is 2 times 9. 2 is prime, 9 is 3 times 3. Notice that when we make these factor trees, it doesn't matter how we start. We'll get the same primes in the end. So our 12/18 now, well, 12 is 2 copies of the number 2 times the number 3. 18 is the number 2 times 2 copies of the number 3. We cancel out a pair of 2's, cancel out a pair of 3's. We get 2/3.